Okay, good to see everyone here. I always ask, who's here for your first time? 1, 2, 3, 4, 5, 6. Wow, good to see so many new people. Let me see. So we're going to go ahead and kick it off. Welcome to Austin LangChain AI Middleware User Group, or AIMUG as we call ourselves. For those that are new, welcome to the crew. For those that are returning, it's great seeing you again. I always say we broadcast onto YouTube. We're not live streaming, but we record and cut onto YouTube. We also broadcast onto, actually, can I ask a favor from someone? Do those windows come down right there? The sun's coming in. Thank you. We also publish onto Austin Public Television. So if you don't want to be recorded, if you don't want to be on TV, that is the place where that will not happen, right? Right here is not. Okay, cool. So thank you so much, Collier. What are we doing today? So we did our intro, 6:20, right? We're going to give a little bit about Austin LangChain for the new people, give you a little heads up on what we do, what's LangChain, how we do what we do where we meet. I'm going to give a thunderstorm talk, so 15 minutes on LangChain 1.0 Alpha, and specifically the middleware features. I did some playing around with that recently. Then we're going to hand it off to Ryan Booth, who's been coding up some really neat stuff. Hopefully I'm not overselling you, with A2A and AP2, agentic purchasing protocols. Very, very exciting. I don't know if you saw AP2 came out recently, but also OpenAI came out with the purchasing protocol too. Agentic purchasing here. For the members that have been here for a while, you've seen Kareem, who I think he's shipping code right now with his job. Hopefully he can make it towards the end. But Kareem demonstrated agentic purchasing here a year and a half ago, right? So pretty cool. Next we're going to Vanika. Are you here? No. Okay. If Vanika shows up, she's one of our high school students that we mentor. For the people that are new here, she actually developed a way of detecting the cancer that killed her grandfather. And it used to take 2,500 hours of compute time. She did it inside of Google NotebookLM. Or excuse me, not NotebookLM. Colab. Google Colab in like 5 minutes. So she's been mentored by me and by us around here. And she went to Stanford, did her internship there this summer. So hopefully she's going to be presenting her research. I'd love to hear it. Next we have Ricky, who's not here yet, who's been doing some really interesting work on AI-assisted cognition. And then we have Dimitri, who's going to give an exploration on inference provider frameworks. People don't know Dimitri. He's like mathematically super smart. Am I right? Yeah. And then after that, we're going to wrap up, and there's an after party that's right down the street at the tavern. Okay. So for those that they want to catch up, so we've actually made a lot of investments in the AV stuff. So all the talks from last month are published onto YouTube, and if you go to AIMUG.org, you can go click on blog, and there's a link with all the stuff. If you click on learn, all of our meetups that we do, what we've been doing is trying to recycle the presentations and put them as study materials that you can use and catch up, right? So I want to thank you to the members who support us. We're community-driven, community-funded, but also thank our corporate underwriters. Our space sponsor here is the Center for Government and Civic Service. Civil Service Civics, I think it's Civic Service. We're also sponsored by LangChain AI out of San Francisco, by my company, Always Cool Brands and Always Cool AI, and then by Toolhouse. They allow us to do things in the community. They allow us to pay for all our streaming stuff. But most importantly, the members allow us to have some intellectual honesty, and so we don't have to be stuck to any one platform. So if there's something that sucks from LangChain, we don't have to talk about it. It's really great. Myself, my name's Colin McNamara. I'm a local entrepreneur. I'm a co-founder of Always Cool Brands. We're a CPG company. We produce grocery products mostly for store brands. If you go to Sprouts right now, they're in distribution right now and making their way down. There's some smoothies that are coming out in our Sprouts brand literally today. as well as a number of other products. We use AI and LangChain and LangGraph to create clean label products which don't have dyes, additives, stuff that make you stupid, give your kids behavior issues. I am not an employee of LangChain at all. I am a user of LangChain and LangGraph. Also a community builder, so started this about 2 years ago. Put a flag in the sand, see which nerds would show up, and thankfully a lot of great ones do. I say nerds lovingly because I'm one. I am a 50% developer. I used to call myself a 10% developer. Prior to 3 years ago, I was in engineering leadership at OCI. Clay McGork, that just got promoted to co-CEO, was my skip level manager. Long story short, my boss killed himself. So yeah, he's that rough. You know, he definitely has got the drive to get Larry another island. So I left that 3 years ago to go do stuff, to go do more meaningful stuff, and this is part of it. In the public good. Who we are, Austin LangChain. So we have 1,600 members here at AIMUG. We learn in the open. So there is no one here to sell you anything, right? We're not here to pitch you. If you come up here, please don't pitch. If you do call to actions, it means I have to cut it out for when it gets onto public television. That's annoying. But we've been riding this wave for about 2 years of exploring AI through actually doing it and presenting what we're learning back to ourselves each month. Okay? It's pretty cool. We are very supportive of each other. That's the wrong way. The big thing here, I talk about learning in the open. Come join us. Join the fun. Got cold sodas and pizza in back. Grab a name tag if you want to. We have 2 rules here at Austin LangChain. Be cool to each other, right? When you're learning something, I know when I'm learning something, I'm like a kindergartner. I'm insecure, I'm unsure, I'm not getting the dopamine squirt from things working. Like it feels really, it's just hard. When you're learning something and be telling and talking to people about it and sharing knowledge, it's even harder. So one rule that's allowed us to be successful this past couple of years is we don't nerd snipe, we don't pick people apart, we're pretty cool to each other. And the other rule, don't be gross. You know what gross is, don't do it, right? Where do we meet? We meet here normally for labs, mixers, showcases, the first Wednesday of the month. If there's holidays, we kind of shift it around, or if like I'm stuck traveling. In Austin Community College, RGC 3000, which this is actually the original gym for Austin High School. Yeah, from like 100 years ago. Fun fact, right? We also meet out on town, right, for hacky hours. We should have another hacky hour before our next showcase. I just have to go to Central America for a bit. I need to know which weekend I'm going before I post out here, but keep an eye out on Meetup for hacky hour. So we go out in town, usually at a local bar, have a brew or a coffee or whatnot. We met Cosmic the last couple of times. We bring our laptops out. Sometimes some people bring laptops, some people hang out, hack on code, talk about stuff, hang out. And then we meet on Tuesdays at 5 o'clock p.m. Central Time on, not Zoom, Google Meet, right? And you can find it by going either to AIMUG.org events. It's listed on there. You can click the button, but also on our Discord. So we have a Discord that if you go to AIMUG.org, Discord button there. Sorry if you use Slack. It gives me PTSD. Fucking hate it. Howdy. So, anywho, so 5 o'clock on Tuesdays, we have office hours. You know, there's usually between like 5 and 10 people on there. And I learn something every day. So what the heck is LangChain? For those that are new, LangChain AI is a company out of San Francisco funded by Harrison Chase, a machine learning engineer that worked for Ilya worked with Ilya. And a couple years ago, I was like, hey, we're writing all these abstractions directly to OpenAI. Maybe we should write libraries and start abstracting. And so over the past 2 years, there's been various levels of sometimes annoying and tortuous abstractions. And then become simpler and simpler. There are 2 open source projects that we focus on here. The open source project of LangChain, which has evolved. It's actually a small portion of LangGraph now. It's much simpler, less headaches. And LangGraph, which is a graph orchestration engine. There are a huge amount of open source integrations here, although with MCPs and A2A and whatnot, it's become a lot easier to integrate. Now, there's commercial platforms, like a lot of us will run within fast API, spin up in a Docker container, and self-host. But if you that's not your thing, you can throw it up on LangGraph platform. And then for observability, you can use LangGraph and LangGraph and LangChain. You're going to end up using LangGraph most time to pop to OpenTelemetry, OTel, or natively into LangSmith. There's basically a web-hosted debugging engine that you can debug your agent workflows. So if you have the agent, you don't know what it's doing, pop it into LangSmith. There's like a small amount of free tokens you get inside of it, and it's like $30. I would say, like, if you use open source project, kick down, it supports thing. If not, it's no big deal. There's a suite of free open source tools that you can drive it into. Arise Phoenix, LangFuse, blah, blah, blah. Yes, Chad?
Yeah, so you may cover this later on in the presentation, but some of us who are engineers who may not specifically utilize LangChain, I just personally understand that transformer-based architecture. That's just drilled in my mind.
Cool.
And I don't use this on a day-to-day basis, so anything beyond that, I don't look to the integrations or the LangChain platform, or LangGraph platform, that is. So I was just curious as to whether or not you cover that future slides or if it was something that...
Well, so like we're just doing a quick intro, and then we're getting into thunderstorm talks. So this is about, you can go and be like, yo, Colin, I want to talk about my learning on like where transformers architectures really transform into abstraction layers and how I use that for my own thing. Like, figure it out, teach us, right? Again, I'm not here to pitch you anything. I am a user. I use LangGraph in production in 3 applications. 5 other applications are native to OpenAI, and like, I don't care, right? If you my LangGraph TypeScript applications, I have also LangGraph in Python. They're easier to manage. And like I was talking to a few people in the corner there about my quote to cash process, where I have to deal with like EDI orders, QuickBooks, and then keying entry for like shipping and stuff. I have 2 prototype applications I've spec'd out, one in N8N and one in LangGraph, and it's looking like LangGraph's going to win because of the human in the loop, the ability to like bring me in. So I'm just a user of this stuff, man. Like, I just use it. Like, I'm not here to like sell you on it. You want to use other stuff? Please tell me about it.
Tell us a little bit more about architecturally what that would entail with human in the loop after already having LangChain as like the base layer. Like, what is that? What would constitute me needing human in the loop for what type of call or what type of...
Yeah. So in this case, I might get an order in for a truckload of smoothies that are going to KeHE distributors, making their way down to Sprouts. So we produce for Sprouts brand, right? As well as other brands. And so in that case, I have to have some sort of graph execute. I have to have some sort of graph, some sort of loop that's polling probably QuickBooks API. I need to like write up an AS2 interface so I can take EDI natively, but it's not fun to me. But that's polling the sales orders inside of QuickBooks that are mapped in the purchase orders that come in, right? And so like a normal size order within norms, I just want to automatically process and let bookkeepers handle it. But maybe I get 3 truckloads comes in. Well, I know that I need to call the manufacturer and I need to make sure there's additional line time. That's a case where there's an exception to my normal, and I want to have a graph execution framework that is saving state into a Postgres database. So if the graph fails, I can pick it back up. I need to have a graph execution framework that if it rolls forward, I can roll it back, right? So those are like, and I need to have a graph framework that natively logs to OpenTelemetry, so I can put it into my OTel collectors, reflectors, and fan out into my observability infrastructure. There are a million other ways of doing it, and oh, hey, Vanika, so glad to see you. There are a million other ways of doing it, and if you know a better way, teach me. Like, again, like I have a number of applications in LangGraph, a number that are not, and I find myself building more into LangGraph because I see it as a trusted framework that like JP Morgan Chase is using, Nuvobank uses, LinkedIn use. So there's enough smart people that are pushing back into it. And the fact is, like, I'd say Harrison hooked me up, saved me from an SEC violation about 2 years ago with his chat with data challenge. Like, he made a friend in me. But that being said, like a lot of us do a lot of other stuff, and we use LangChain and LangGraph as a tool to tie in the large ecosystem together. So like we may use different RAG frameworks, we may use different data structures, we may use different cloud platforms or execution platforms. We may use different observability stacks and whatnot. And we use LangChain and LangGraph as a tool to drive that conversation. Not everyone here uses LangChain and LangGraph. But the way the ecosystem pulls together, we're able to contribute back to each other's knowledge. And kind of, it keeps us on track a little bit, you know? But yeah, everyone always asks me, like, why aren't you using this new thing? Why are you? I'm like, I'll play with it, I don't care. Okay, so I just went the wrong way, didn't I? No?
Also, if you go to the AIMUG org site, inside of the documentation section and presentation sections, they did a number of presentations over the year or two on LangGraph and LangChain basics and those details. So there's a lot of good resources there.
Yeah, go to AIMUG and learn. And we've tried to actually go and like, it's been this like, I wonder if we can do this, of accelerating our learning, having our learning, our talks captured, transcribed, generate documentation, have that picked up by the agents that are putting that information back in the world and accelerate, not only in our community, but the world at large. Yeah, but, okay, so today I talked about, we have talks and demos. I'm gonna give a little talk about some learning that I did around the LangGraph 1.0. So we're about to go into stable non-breaking releases. We're in 1.0 alpha right now. 1.0 something 4 with Lang, it's in my slides. And then 1.0 alpha something with LangGraph. So in this month, we're like going to like the stuff I have in production. I can be a little bit more comfortable with it. Next, I talked about, we're gonna have Ryan Booth come up and talk about agentic purchasing and AP2 and some of his demos and stuff where he's been exploring. Again, that's not LangGraph, but you can put it in front of LangGraph, LangChain. Vanika, hi. Oh, hi, Mom. Yeah, Vanika is going to give 15 minutes and talk about, present our research from her internship at Stanford. Ricky, he's always like, he's working hard. Hopefully he'll be able to make it in time because he's been doing some really interesting work on using AI to assist cognition. And his last statements about using AI to do failure mode analysis really blew my mind. So, you know, there's this notion, and actually very similar to where Cloudflare's latest blogs on using AI to generate TypeScript APIs in front of MCPs allows you to optimize your context utilization. They do that because there's so much TypeScript out there that you can code TypeScript super easy with agentic programming. What Ricky found, and he builds stuff that builds chipsets, was that these engineering platforms, your Lean Six Sigma, your lean analysis, your failure mode analysis, all that corpus of knowledge is actually trained in those too. So instead of like going through step by step on this complex thing in your prompt engineering, you can literally just say do a failure mode analysis. So he'll be talking about that, and then Dimitri is going to talk about inference provider frameworks. So now I'm going to kick it right off and get into some of the work that I did on exploring LangChain middleware. So who saw LangChain middleware release? 1, 2, 3. Okay, cool. So LangChain middleware is really, really interesting, and I'll ask questions. So who's built an agent that's gotten out of control, that went apeshit? Come on, raise your hand. I have, right? Who's manually managed your token limits? I'm deaf. What?
Yeah, I cannot hear you well.
I can't hear you.
Is this connected to my speaker?
We're not going to troubleshoot our AV system right now. Thank you, though. Is it coming out the speak? It's speaker. Hold on. Headphone up. This is the speaker right here. Test, 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 test. Okay, cool. Thanks. Sorry. It's very hard to give a present. I'm actually an introvert, by the way. I have stage training, but this is incredibly uncomfortable for me, so sorry about shutting you down there. But I can't hear you. Troubleshooting an AV system while trying to do a presentation. That right there. Remember rule 1. Okay, so who's played with token limits, maybe put caching layers in, who's had your agents blow stuff away exactly, right? Who's thrown a lot of parameters, stack parameters to fix things? We've all had to do this, right? Who's wished that you had a way that a human could pop in for human in the loop? Me, we're just talking about that. And is anyone screwed with state management for just dicking around with it? I mean, about 2 years ago, it was all we were doing. One of the reasons I like LangGraph. So in the old days, we had a huge amount of parameters that we throw into our agents, right? Now, for me, this is called AI Middleware Users Group, right? And I come from WebScale, which became Hyperscale, which became other stuff. And so middleware drives the world, right? So what if you could implement middleware patterns in your agents? So what LangChain did with the 1.0 something 4, came out just a few months ago, or a few days ago, should I say, a few weeks ago, is they entered in 3 different hooks for a middleware function, right? So you can go ahead and have something that inspects your calls before the model. I think this actually has. Oh, look at that, right? So you have your request, right, enters the flow. You have a hook that is literally before underscore model that will allow you to inspect your inputs, augment your inputs. You can modify the model request, so when the request coming into the model, and you can modify, by the way, I hope Ricky shows up. Okay, one more in create, so cool, sounds great. And then you can put like safeguards on the output, right? So the 3 hooks, I talked about them, right? This is actually a really good graph. This I wrote a post on my blog based on some of the testing I did on ColinMcNamara.com, where literally middleware.perform model, you can go into an observation, right? You can modify that request, and you can basically do the output, or you can bypass it and then do an after model hook into it, right? Pretty neat, right? So your before model has a couple things that you can do, right? So you can update the agent state. You can jump to a different node, which nodes on the graph, right? You might have like my agents in my graphs now are, each function is effectively a node on the graph, right? So I can go ahead and modify and jump to a different step. You can manage your context, which is really neat now with this. So you can say, like, who spends like half their time in Claude Code or Codex, you know, scape, up, and managing your context? Oh, Panika, I'm glad thank you for raising your hand for that. So you can actually, using the before model hook, you can actually have built into your agent description, you can say only keep 20 lines, right? Only keep this many tokens, right? And then you can implement guards. So if you like Nemo guardrails or something like that, you can make sure it doesn't go off the reservation. So hook 2 that you can do inside of this. So 1, you can swap models on the fly. So in your agent description, so has anyone had like cost runaways or cost expansion? You've had it, right? I have, right? One of the reasons I like Llama so much, right, is that I don't have to stress about it. But you can basically do a model router based on the complexity of the query that comes in. Put it right in the middleware. You can say this is the 4.0 mini. This goes to 0.3, whatnot. You can also dynamically adjust the prompts, which is really cool. Based on that modified model request, you can bring tools in and out of scope, another context management, but also security and safety, right? And then you can also, like, my favorite meme, I actually have a t-shirt of this that Ryan made, is from, oh my God, I just blanked on it. Ryan, the shirt, it is from Rick and Morty, right? Where they make they make an artificial intelligent robot that becomes sentient, right? And the robot's job is to like sweep, right? Like, I know I am something, and in the meme shirt, it's like, what is your purpose in life? Like, my purpose in life is to format JSON, right? Exactly. So you can change your output format. You can pop into JSON. You can structure it. You can text or other structured outputs. Pretty cool. Other thing that you can do, I ran some numbers. I don't know if these numbers are BS or not. I'd be curious if someone puts this into production to be able to validate that. But you can put caching middleware in your agent, right? So like one of the last projects I did, I ended up using a lot of Requesty because it had a really cool caching layer, right? And great visibility onto it. So now with the middleware on here, you can literally put your caching layer in your agent. So good optimization, save some money on top of here. The estimation was for like a 1,000 user agent was like $5,100 a month. I don't know if those numbers are real or not, but we'll see. Other examples here is dynamic behaviors, and I took these from my blog post, and I basically took what Harrison and team did on their blog post release, but then they also implemented these. And has anyone used deep agents yet? So deep agents are like a Claude Code clone inside of an agent, right? And so they updated deep agents, so they use LangChain middleware now, right? And so you can create dynamic behavior. It's pretty cool, right? Next is you have your after model hook. So you can inspect your outputs. You can implement circuit breakers, which are really, really cool. So halt execution if you are if the output is unsafe, doesn't meet expectations, is not within the scope of what you decided it would be. You can implement human in the loop. So we had like why do I use this stuff, right? That I gave a use case. So an order comes in the system, which is going to be automatically chained down and results in a purchase order an order for manufacturers to make something. If something is above capacity, I want a human to look at it and like not piss off my manufacturers. You can collect metrics in here too, so you want to pop this in like OTel and whatnot. But this is the big thing, you can do anomaly detection. So neat thing here is within this middleware, human in the loop is like really easy to do, right? Where is it? See that interrupt? So human in the loop middleware, interrupt on, stupid commands that the AI does. Delete my database. Require approval for this tool, right? You want to send an email out to my customers. Require humans to send the email. You want to read data. False. You don't have to deal with that, right? You can do composition, which is really cool. Which is you can basically stack things together or chain things together. And then I talked about this early. I don't know if this math is BS. But the caching layer seemed like really, really interesting, and there's been use cases where, like, I've had use cases where I've had to build systems that are in like a US Gov Cloud or something like that, and I can't use Requesty, I can't put a caching layer. Being able to put a caching layer in the graph or in the agent would be really handy. Like, I would have used this. Other gotchas that I found, I documented these on my blog. It's alpha code, but you have to basically explicitly define tools. You have to actually define your interrupts, else it won't build. You have to what's called you can't be generic. You have to specifically call a summarization model, and then your check pointer, you have to explicitly call it out, right? So if you have that empty, it's not going to build. So in this case, we have you can build your own middleware in with just 3 methods. So this was like a lot of work before. So this is my sample. This is the thing I put together for like me using it. Right now I'm not using deep agents in production yet. I'm waiting for OneNote to stabilize. I got to do some stuff with my FinOps infrastructure. This probably will make sense with my FinOps infrastructure, like what I was talking about with that use case, orders coming in. That's kind of what I'm looking at, over a month when things settle down. And I talked about my test results. And then, so if you want to play with this tomorrow, you can install LangGraph Alpha and LangChain Alpha. So 104 Alpha for LangGraph, Alpha 10 for LangChain. Start with your summarization, log it, see what happens, and share your results. For people for resources, everything you need on this, and this is actually in the Austin LangChain repo, and it'll end up in the AIMUG. What? Oh yeah, no worries, man. And these are all recorded. This will be on YouTube, and this will also be on our notes on Learn. So I posted a blog on ColinMcNamara.com. It was just a study guide where I post my notes, where people can use them. The docs are at langchain.com/middleware. And then I hate Slack, but you can hop on the LangChain Slack, or you can log in our Discord. So that's me. And I want to give it up onto our next presenter if anyone has any questions. So they should be uploaded to our presentations under, if you go to AIMUG.org, on the upper right there's a GitHub link. And click on there, it's under like resources, presentations. This slide is. And then what happens like after our talks, everyone cuts PRs. And then if you go to AIMUG.org, click Learn, and then the month. Like if you click on September, you'll see the links, the descriptions, you'll see videos, about everything. You're welcome. Any other questions? Awesome. Okay, cool. So then Ryan Booth, will you come up?
Of my presentations here. All right. Who's seen a working one? Oh, yeah, right. All right, and the rest have seen the ones that don't work. Right now, I'm batting 0 for any of my demos to actually work here. So, you know, you can't have too much confidence in me right now. But this one, luckily, is not to actually demo a working solution. This is more of a exploratory task, sharing information, sharing where I've gone with this and what my mind is kind of pushing through as I explore these topics. This is very much a presentation to open your eyes or help you see things different ways with how we could utilize these tools. I'm not trying to cram anything down anybody's throat right now, but just kind of present what I have. And if the demo gods are working, we will have a demo that won't work 100%, but it'll work with what it needs to. So, so starting off really quick, who all here is familiar with A2A and AP2 already? Okay, quick primer on it. For those of you that have been to regular meetings, I apologize. Agent to agent is a protocol that was released by Google. It's an open source protocol. And basically it is a process of taking agent-based traffic, AI-based traffic, whatever you want to roll into the term agent, taking that traffic, separating it into a separate protocol, and allowing it to handle more like discovery-style tasks. I see a lot of resemblance in what's being done here in the SEO world, in the areas where people are trying to get their information out there. And it makes a ton of sense because it's getting into this notion that similar to car radios, all of them kind of turned into an aux port for your iPhone. Everything is going to be turning into you get all of your information through your AI chat assistants. So as a business, as an entrepreneur, as a marketing team, as a CEO, you know, your customers are not coming to your websites anymore. Your customers aren't going to look through your product catalog. They are going to ChatGTP and telling them what is the best product to purchase. That is a lot of where I see this, but I'm going a completely different direction now. The areas to key in on here, it's an open protocol, like I said, core ideas. There is verified authentication between the agents with A2A, so you do get that capability. Like I mentioned, capability discovery. This is the one I'm honing in on the most tonight. Basically, you are saying as a business, as a person, as a brand, as a company, my capabilities are X. And through the searches inside of the chatbots, through the LLMs, through however they're working, they will find through the A2A protocol off of an exposed API all of your product catalog, all the information that they want you as a customer to know. This gets into a lot of really cool workflows. Someone who desperately needs tech support on their computer takes a screenshot of it with ChatGTP and says, how do I fix this? And then they get a contract service or a service out there that can install something and do it. This is obviously a very made up story. But then they can pay for the transaction right there inside the chat with a reliable customer or a reliable company. So that's kind of what I'm going to dig into a little there. There's also, you got like internet exchange handoffs, anywhere supply chain that could be working with this stuff. Agents can be getting in there and walking through transactions. So then the AP2 protocol, agent payment protocol, came out last week, I believe, or the week before. And this basically allows them to start handling transactions, physical money transactions across the protocol. And so now, instead of just doing handoffs and then you deal with billing later, the actual billing aspect now is built into the chat. So when customers get your solutions back, or they get whatever that it is inside the organization or inside the chat, they get the details back, and then they get the option to pay for it. We're starting to see this hit the market now. There's a ton of integration from all of the big players. PayPal's already on board. I'm not going to speak to any of the others because I would probably be lying, or I don't know what I'm talking about. So I'll shut up there. Questions? Those were the basics. Anybody else want to cover anything I mentioned? Questions? Can I clarify anything? All right, cool. So here's what we're going to do. We are going to build a prototype that runs through this transactions journey. What I did is I've been working for the past year plus, on doing a lot of automated software development. My whole notion and what I've latched into is complete hands-off on software development and how do we fix it. So I rolled this straight into that one with the notion that inside of an automated workflow with LangChain, and I actually use LangGraph in this demo. So you have a workflow that steps through the process of selecting the agents. Sorry, I was getting a little mixed up there. And with that, when you go to get something built or you go to do something, be similar to like eBay or any other market site, you say, I need these types of capabilities. And it finds all the different agents, it finds the custom trained models, fine-tuned models, whatever's out there that offers up the type of services that your project needs, it gives you the ability to pull those in and then work with them. And so that's what I wanted to test here. I wanted to be able to grab these A2A queries, being able to hit capabilities and find in a market where people have agents available to do work and someone requesting software and it happening. And so that is what we're going to do. The notion of it is basically as a user goes in and requests new software, the LangGraph workflow, well, let me just show it. I need to do that. Let's make sure we're here. All right. Can everybody see? Well, you'll see it better. So Corvera is the name of this kind of like ongoing software development project I've been doing. Yeah, it's just kind of my own thing. So that's what Corvera is. So here, can y'all see that well? No? Zoom? All right. So here we got basic selection. So what I have built into this right now is you can come in here and you can request software development. Rolling into my previous presentations, you essentially add a project name, chess game taco cats. That'll work. We're going to build a chess game, hopefully using characters of tacos and cats versus each other. So budget and stuff, these are kind of fake numbers. This is all kind of just to show how transactions can be set up and how this can be planned out. Timeline, 30 days, why not? Description, basic chess game. Okay, requirements, must use tacos and cats as pieces. PvP and PvC play options. Add. Okay, so this is kind of capabilities I'm leaving blank for this very reason right here. So here's what happened. We put in what we would like from a application. All right, it actually failed. I gotta love it. So what happened is it was working off of the A2A capabilities and working through the information I built into the form to say what are the agents available that can build this software. And we have a nice little bug here. So like I mentioned, there's also services that I put in here. And I can go back in a second and show you the different services. One of them is a taco stand. All right, taco stand, one of their menu items is a taco. So obviously from the information I put in the description, it keyed in on tacos and not software or a chess app. So I should probably redo that. Let's try that again. No taco caps. Regular chess pieces.
I mean, you're in Austin, so like having tacos and AI together is actually incredibly appropriate.
Okay, let's, all right, fine. All right, here's our agents. I got a coffee shop. I got Codex Orchestrator, so we can go ahead and just go into it. Each one of the agents in a LangGraph workflow kicks off whatever the workflow is that someone is providing. Oh, a pointer. You don't know what you just did. So basically, we have an agent here that says at $10 something or other, it'll you orchestrate the code development using Codex. We have an insurance company, lawn care, so you can kind of see how I set this up to kind of show multiple different approaches. I also have Cloud Orchestrator here, and there's our taco place, and then I'm also building in local OLAM integration as I can get there. So let's do this again. Chess game 40 timeline 30 days and description. Get that added. Create. Yay! Now we have better. Okay, so we have two options here. We have a Codex orchestrator and a Cloud orchestrator. Let's see. This is kind of the main part of what I had from a demo-wise, because it kind of shows and highlights where some of the ways you can look at this, and this is very much from a marketplace standpoint, kind of ripped straight out of like AWS. But you see that the available agents are there. We recognize that when the agents need to be spun up and loaded and ready to go, it's there for the demo. Specialization is an orchestrator, not going into too much depth. And then, of course, you can do price comparison and ratings based on users to kind of give you the general picture of what's there. But what we're going to do is we're going to do the Codex orchestrator. Works for me. He's got 4.6223649. That's pretty good.
It's a very accurate score.
Hey, agents demand detail. Let's start the work here. If this kicks back an API mirror, hey, it's going, yay. All right, so this is all kind of, it still needs a lot of cleanup. But essentially what this is, here's a workflow we're running through. Essentially, it's going to establish intent and requirements to be built out. It's then discovering the agents that are and their capabilities. Are they available, ready to go? Capability negotiation, blah, 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 blah. Contract assembly. So this is one of those key things. It doesn't matter really how you apply it here, but here's what I'm going to say. Contracted-based agents is going to have to be how we build critical software. And I'm not just talking about building product designs. I'm not just talking about building engineering docs, but taking a capability through A2A where you can actually negotiate contracts and have them executed and have them validated. I think that is how we have to go to get to critical software development at this level. Anyways, that's just my opinion. So it runs through its deal. It builds all the stuff. It's actually building right now, hopefully. So that's essentially what it is. And when everything comes back, it will all get dumped into an artifacts folder. And when everything completes, you will see everybody getting paid. And that's it. So while it's waiting to die and crash, questions?
Yeah, well, I'll start with one. So you implemented A2A inside of this. So which side is actually implementing the A2A service discovery and service offering? Yeah, so you have like a Codex agent, you have a Llama agent that's exposing a service. Can you expand a little more on like how your project execution is querying these agents for their capabilities and negotiating the cost?
Yeah, so when an agent is added to this application, we look for the capabilities and how they register with the A2A. Specifically, I did it to use A2A to find capabilities because the next thing I'm going to do is allow someone to set up like a third-party website, expose their A2A catalogs through that, and then tie it into this tool as well.
So do you see this as like a service advertisement framework for your agents or graphs?
That is really the biggest use case I can come up with right now. And it was one of those things I'm fielding out to everybody here. I'd love to hear other use cases on this. Oh, hey, it said that it worked. It didn't work. It's not going to work. I'm still doing a lot of work, so that's pulling in through the OpenAI Codex SDK to integrate with that. So it's literally just firing up a Codex session and having it do all of its work. It does the exact same thing with Claude Code. So let's see. My other pages. So if I can come into my, I used to have like details and stuff on what was done with the agent, its transactions, the ledger and all that stuff, but I've lost that in the refactoring.
We'll record it and all that, and it'll be.
So that'll have to be a next time type thing.
Cool, awesome.
That's what I got. I hope everybody enjoyed it. Oh, yes. I'm sorry, I can't. Yes, and there's a pretty good chance it's already partially showing up there, in there. So that type of stuff, you want to go into your SEO settings. And I've noticed a few of the places, especially like website builders and different places like that, they stuff them in there. But they should have those settings. And you're looking for stuff like a robot.txt. They take a lot of the same approaches for SEO with AEO as well. But that's where I would start there. And if they don't have it yet, Shopify is probably going to have it pretty dang quick.
Shopify already released an MCP where you can actually connect to your Shopify via the MCP and get access to the entire Shopify corpus. I haven't seen A2A on them yet.
Cool.
But yeah.
Okay. So with an MCP, you're basically now, instead of interacting with a UI, interacting with a API, you're interacting with an agent that talks for you to the MCP.
Awesome.
Yeah. You had a question, right?
Oh, sorry. Question.
Oh, well, it was, kind of getting in the weeds about service providers and whatnot. When we think about service organizations and when you're like contracting with them, you do have things that are like clauses about craftsmanship, and then you also have like, things that happen in terms of how do you cancel a project or how do you add on to a project. These are change requests and whatnot. That all happens in the human world.
Right.
And then, well, in my mind as this was going right through the flow, it's like, what if it's like while it's thinking you cancel it halfway? When you talk about the A2P aspect of this, is the remuneration, is that committed at the beginning or is it committed at the end? Is there an escrow in the middle? Like, I'm curious about this.
I am too. I don't have the answer to that.
No problem.
I have not gone deeper into the contract side of all of this yet to understand how that is. Does anybody have that answer?
I've only done service advertisement for like listing, searching, enumerating posts. I haven't tied it into any sort of like smart contract or something like that. I've only used it for like exposing interfaces that you can consume like my blog and stuff.
Yeah.
Yeah, it's really interesting.
And you brought up a point that I wanted to make sure and bring up for the questions earlier about human in the loop. Each one of these steps right here is one of those that would be a smart place to add human in the loop. And especially the later steps Right now, you can't have agents pass money around with A2A or AP2. You still have to have human in the loop. So you have to inject a human somewhere, and usually at the validation and review when the artifacts have been dumped. That's probably a good time to do it. That whole space, though, needs a lot of work. I personally haven't seen many talk about it. Yeah. Oh, right over here. You were first.
So, I don't know where did I get lost or something. So, what you're trying to achieve, this is what I understood. So, you have a kind of like a software that was running a local host, and you put in some information about the software, like a chess or something, and then you generate. So, I'm assuming that, for example, you're a software company and you wanted to build a custom, correct? And you put information about the software somehow, and then the agent generate the deal based on some LLM or something. That's what you're trying to do.
There's, I haven't gone in depth into how that's handled. I've just done simple, just proof. So it would be however you'd want to set that up. And it doesn't necessarily have to just be a software company. Maybe you're really, really good at building a certain type of model that does a certain thing. And when it's tied to a project, use my model. It's 30 cents a minute or whatever the hell the charge. What's the goal?
Yeah, can you repeat the question?
Yeah, so the goal of using A2A and AP2 is to have agents communicate the contract, negotiate the contract, establish it, and then pay for it when it needs to be paid for. Okay. In this workflow? Yeah. So first thing, right off the top, the intent requirement. So that's taking everything I entered in the form, and that's turning it into a PRD that gets handed off to the agent we contract with. So agent discovery is where we find them, and then capability negotiation and contract assembly these are the steps right here where that is set up. And it's not in there. Nothing's in there. Yay. So these two are where they would set up the contract, and then the authorization and signing is where they close it off. Then we do the work, and then validation and review and payment routing. So that's kind of where all those steps happen.
So where's the authorization? If it does the two agents needs to authorize.
Yeah, it has to do it closer to setup. So I'm gonna have to stop there. I'm getting cut off. I'm sorry. Let's chat more if you want to after this. Yeah, I'll grab your question after a bit. Okay.
I'll encourage everyone to continue the
Hello
conversation.
everyone, I'm Vanika, and recently this summer I did an internship at Stanford University at the Donna Sakaran lab, and it's really just a research lab in the Stanford School of Medicine, and yeah, let's get started. So I'm going to talk about the lab today, and I'm going to talk about the procedures that are done at the lab. I'm going to talk about my project on data analysis, and the results that I found from that, as well as my future GNN or Graph Attention Network implementation in the future. So let's talk about the lab. So I interned at the Donna Sakaran lab at the Stanford School of Medicine this summer, and what this lab focuses on is gastroenterology, which is the study of the digestive system and the organization, structure, and all of that that deals with the digestive system. And basically, mostly they focus on the liver. And one of the main liver cancers is hepatocellular carcinoma.
Just put it right there. Put it on your neck. Your sweater. There you go. That works. Thanks.
And one of the main cancers that they focus on is hepatocellular carcinoma, and that is a liver cancer, and it's the third leading cause of cancer-related deaths worldwide. And some of the procedures they do, I'll go over that in the next slide. And one of the most important things that they require nowadays is the use of technology in biological data collection and bioinformatics in general. So I'll go briefly over the procedures that are done in the lab. One of the procedures that they do is immunohistochemistry. And in that procedure, they try to find out where exactly in a certain tumor region are different cells located. So as you can see with this picture right here, you can see that there are different colored areas, so there are more brown areas and some white areas, and that shows where certain cells, such as maybe immune cells or tumor cells, are located within a region, and this helps researchers figure out where they need to target the cell, or where they need to target the medicine that they're trying to deliver. Some other procedures that we're seeing is cell culture, and cell culture is pretty much where cells are grown in the lab to be researched further, and cryostat is when there are small samples of the tumor, and they cut that, and they make sure that they can put it under the microscope to view. And curio is when they try to see what proteins are manufactured in each of the cells and tumor samples to further understand that. Now let's talk about my project. My project was on angiogenic influence, and this is a really heavy data analysis-based project. And I think that data analysis is the first step towards creating a proper AI or machine learning model. And this is really what I focused on most of this summer. So there were 4 parts to my project. It was the direct interaction study, where I studied the interactions between endothelial cells. And let me just clarify, endothelial cells make up blood vessels like capillaries, and they deliver blood to tumors. So they're an important part of how tumors grow and may progress in human hepatocellular carcinoma, which is the liver cancer. So that's what I was studying here. And angiogenic just means the growth of these endothelial cells. So the direct interaction study was I studied the environment around those endothelial cells within 30 to 50 micrometers of all of those cells. And then I did an indirect interaction study, and this was the 100+ micrometer study of these environments situated further from the endothelial cells. Then I did an MVD analysis, which is a microvessel density analysis, and this is when I pretty much split the tumor samples into a grid to analyze each grid square to see more small-scale differences. And then finally, I did a clustering analysis, which is trying to see which cells are clustered closer together and which cells are more dispersed to see if that affects the cancer growth as well. So the data I used, codex in this sense does not mean the AI agent used for coding, but it is a type of software that is able to classify these different cell data and make sure that they're in the correct spatial locations. And that's the data set that I have right here. So this shows the cell IDs, the cell types. There were 13 different cell types, the cohort, whether it was primary HCC, so the first occurrence of the tumor, or residual, which is the second occurrence or more occurrences of the tumor. And X and Y coordinates are just the spatial data or spatial coordinates of each of these different cells. And over here we have this last column, which was kind of irrelevant to my study, but it just shows the protein expression levels. And each of these rows, there were about 1.4 million different rows in this data set, and each of those rows represented a different cell. So just to show how I was able to analyze the data, if you try to graph the cells, so from that data set, one of the regions, and there were about 124 regions, one of the regions looked like that, and as you can see, there are all the cell types to the side, and you can see all of them on this tissue map over here. And you can see each of the different cell types and how they may cluster. So this was kind of a visualization of the type of data I worked with, just to help you understand it better. And here are some of the tools I used for data analysis. So most of my programming was done in Python. I executed in PyCharm and the Jupyter Lab. And some of the libraries, Matplotlib, I believe, is a great way for creating graphs. Pandas and NumPy for Excel handling. And SciPy is great for research work. So first, let's start with the direct interactions. So over here, we have 2 different graphs. These results are from the direct interactions of different cells in the tumor microenvironment with the endothelial cells. So as you can see, I wrote 30 up there. That just means 30 micrometers. So within a radius of 30 micrometers of the endothelial cells, these were the different types of cells that were found within that radius. And as you can see, it says primary. This was just in primaries. There was like more than half of the other data was in residual HCC. And over here, you can see different patterns, such as an increase in the number of fibroblasts as the tumor cells decrease. So you can just try to find different patterns in this data set. And down here, the graph below this is what really matters in biological research. And this shows the significance of the differences between the cell types. So the green bars mean that there's a significant difference between the cell types in primary HCC and residual HCC. So that can show whether there's a difference between those 2 tumors to see how the tumor microenvironment changes over time. And as you can see, I have a summary of some of the results that I found. Just note that this is just a fraction of my data. I have a lot more data, but this is just an overview of what kind of results can be found, and I'll talk about how this can be applied later. And then I also did an indirect interaction analysis. This is when I saw the type of cells that surrounded endothelial cells in a farther radius. So from 100 to 200 micrometer radius, I saw the type of endothelial cells around, or the type of different cells around those endothelial cells. So farther away from endothelial cells were more tumor cells, and it's kind of blurred out there, but there were more fibroblasts farther away. So that might show that there is immune exclusion. So there are less immune cells getting to the tumor and more blood cells getting to the tumor instead, which shows that this may help tumor growth instead of limit it. And these can show important insights into how researchers can tackle the problem of cancer growth. And then over here, I think MVD analysis was one of my most prominent results. So I'm just showing a visualization of how I did the analysis. So what I did was I split each region. So this is one of the 128 different regions. I split it into an 8x8 grid. And as you can see in each of those grids, there is a certain number of cells. So with that, I was able to take the cells in that grid. I took all the endothelial cells in that grid. I divided it by the total number of cells in each grid. And I was able to normalize the values based on cell type and apply that and average those across cohorts, such as primary and residual, to see and compare differences in the endothelial cell environments. These were some of the results of that MVD analysis. As you can see, I have a box plot over there, and then below it is a simpler representation of the box plot. And what this shows is I split up the regions, so each of the grids, I split them up between low MVD, which is low microvessel density, so less endothelial cells, and high MVD, high microvessel density, more endothelial cells. And I was able to compare differences in each of the different cell types based on the microvessel density. And as you can see, there are different results over there. So some bars are higher than the others, which means there are significant differences in the proportions of cells around these endothelial cells. And this just provided more insight into how these tumors look like per cell. And then finally, I did a clustering analysis. With this, I was able to employ Voronoi tessellations. And what these are is that it takes each data point and it finds the average distance between that data point and its nearest data points around it. And it draws a line through that average distance. And it does that for each and every one of these data points. And in this version, each and every one of these cells. So as you can see, there's so many lines on there. And what I was able to do with this is, as you can see, some areas are bigger than other areas. So this shows whether some cells are more clustered together or some cells are more dispersed. And with this, I was able to normalize and average the results across regions and cohorts, and I was able to plot that data. So as you can see, that graph shows a difference. So residual HCC may have a higher number of, a higher area around these endothelial cells, which shows greater disbursement. And then finally, more of the AI implementation. All of this data that I have gathered, it can all be used to understand and analyze the effects of the spatial clustering and spatial distribution on the tumor microenvironment. So that's where I can use GAT, which is a graph attention network. And this is a type of machine learning model, a type of GNN. And what it does essentially is so you see the circles, those are called nodes, and they take the cell information. So you could say what cell type it is, and then you could also put in like patient data, like this patient is this many years old, this patient has gone these therapies. And you can try and understand the spatial interactions, how that compares with the clinical data, and how those two can combine together to try and predict the probability, so with the softmax layer, the probability of recurrence or the probability of this cancer worsening. So I was thinking graph attention network integration would be a great way for me to proceed with this. This is just an overall framework of what I would try and make this look like. And yeah, I'm still working on this part. And yeah, that's it. Thank you all for listening. If you want, I have more of my projects on my LinkedIn, and then I also presented a more AI-based presentation here in March. You can also look at that over here. Thank you.
Okay. So, Vanika, you mentioned that you're using GNNs, or you're developing a GNN method for cancer detection. How is this related to your earlier research where you, in a revolutionary way, were able to detect the cancer that killed your grandfather with fractions of the resources previously done?
Yeah, so my previous research was on the thermostability of the proteins around that cancer. So what that does is it is able to detect how fast the cancer can progress. So I can also implement that data, or that I can also make like a multimodal ML machine learning model. I'm still thinking about that for now. But yeah, those are really both great ways that they can try and predict clinical data, and using clinical data, they can predict the recurrence of cancer and how this can progress, and the probability that a patient might get this cancer more than once, or the probability of their survival if I'm able to integrate more data with this. So those two models are very closely related because they both provide like valuable information that can be used to predict the onset of this cancer or the recurrence of it.
Awesome.
Yeah.
What other questions do we have for Vanika? Well, Vanika, thank you so much for taking the time to share this.
Thank you.
Literally blows my mind. So really proud of what you've been able to do with the opportunities that they extend you at Stanford, and looking forward to hearing back about further developments in your research. And like, who knows, you can spend time at MIT next, or are you going to go down to Stanford for the rest of your education?
Yeah, that's my plan.
Yeah? Awesome.
Yeah. Stanford is really nice. And about this, actually, I'm writing a research paper now, so I'm in like the publication process. And yeah, my research paper has a lot of this information. Once it's published, I'll try to share it with you guys so you can learn more about it if you're interested.
Awesome. Well, we're so thankful that you had to take the time to share your research with us. And you know, Vanika is one of the students that we mentor here. We mentor students. You're actually in high school.
Yeah.
Can you drive yet?
No, I'm going to learn. I'm going to learn.
So you're going to learn how to drive, but you really learn how to detect cancer, and the probability that if you get cancer, it's going to come back, it's going to kill you. Not you, but all of you, right? So I think your priority is in the right place. I'm really inspired.
All right, so today we're going to talk about LLM inference providers, and those mostly being the options you really have to how to run LLMs locally. I'm not going to go into any of the cloud ones. Mostly because they're just self-explanatory, and plus I really think you could get a much better deep dive from those providers. And fundamentally, like, if you're going to go call OpenAI, Anthropic, or any of those guys, they figured a lot of this stuff out that I'm about to show you. So first of all, let's just walk through what those providers are. So I'm really going to go through like the ones you have locally, like OLLAMA and Llama CPP, the Hugging Face Transformers, VLLM. And then at the end, actually give you a comparison, like at a glance, and some key takeaways when you actually look at them all. So the first one I actually put down was OLLAMA and Llama CPP. You do see the slash as OLLAMA is just a wrapper of Llama CPP. They just make it easier to download models. And mostly what they're really focused on is that they're really focused on just running things locally, with ease. They really focus on this GGUF format there, and I'm going to get into in a bit what that really is. And it's great for a quick demo, but again, because it's around that GGUF format, which is really designed to be a binary format that's easy for CPUs to run them, which is the other reason why a lot of accelerators have really picked up on them, mostly being that they're really easy to pop right into like an M1 chip. You also see like AMD, for example, has some products where they have the CPU and the GPU together. So that's why you kind of see that format take off. It's just easy to run these two things. But of course, the first problem you're going to run into is outside their immediate use case of just I'm chatting to this model, they really do not have any batch sort of processing. So if you want to just take, a big PDF, you want to send every one of those pages to OLLAMA, you're going to run into a whole lot of problems. And really the second one is that it's opaque in memory usage, which means, and I encourage you to try this if you have a GPU. Go to your OLLAMA, and then you can type in OLLAMA PS. That's going to tell you where the models are and they're loaded, which is going to tell you how much on GPU and CPU. As you increase the max sequence length, you're going to see it's going to make decisions on how to move the model between the CPU and the GPU, which is not ideal. And in fact, it can be very subtle that you're going to suddenly find, I have a GPU, why is half my model in the CPU when I'm not expecting to hit crazy tokens, which again, not ideal. That I actually argue should not be the case. You should be able just to tell OLLAMA of, hey, I want you to keep this on CPU, I want you to keep it on GPU, but that is not what they're about. So again, you could try opening a ticket, probably they're not going to actually address it. And finally, not tuned for production, again, for the reasons I said. Now, there are things that you can do in there, like you can set how many models can run at a time, how many requests can that model serve. On the surface, they look great. They're not batching, though. If you actually look at serving one model and having concurrent requests, it tries to spin up like their own token limit, so you can quickly just run out of memory real fast on a MacBook. So let's go to the next one, which is Hugging Face Transformers. This one's made by Hugging Face, and it's a really amazing inference stack in that you have all the fine-grained controls you would like out of Hugging Face Transformers. You can tell which layer goes on which device, which accelerator gets used by which layer. They really do let you go layer by layer and decide where on the GPU will this be. You can also partially shard layers too. You can say half of your layer will be on one GPU and the other half will be on another. And that's great for that. It's also very featured. So anytime there's some new development, Hugging Face is the first to actually have it. You know, for example, flash attention, that's not really something OLLAMA has. I know they've recently pushed it for just GPD-LSS, but again, flash attention's been out since 2023. How come none of the models have it on OLLAMA versus this is really trivially easy to set up on Hugging Face. Again, I'm going to just skip how to install flash attention, but all you need to do is just tell your Transformers model, I want to use flash attention, and the rest will just work just fine. So to give you an idea, running Quen 2.5 VL, the 7 billion, with OLLAMA through 20 pages of images for OCR took me about 35 minutes on the 3090. This took like 8 minutes with Transformers. Even though I had a much more aggressive quantization on Transformers. Transformers does have quantization. Some of those are actually better than the GGUS. For example, AWQ is dynamic when it quantizes, so you will practically have full precision of your model during the quantization there. Now, some of the drawbacks is, of course, I mean, it's developer-centric. You're really going to have to know what you're doing with your model. If you really don't understand, like, what are some of those offloading or sharding parameters, you can move your model in weird ways that is going to slow down your run very significantly. There's also the other thing is there is a steep learning curve out the box. In fact, all of these models are actually not standard. That's something that Hugging Face has decided to do. It's the opposite of what, for example, other providers like, for example, PyTorch, they just want to standardize on one interface. Hugging Face just said, look, you could put up a model, we'll have a different backend, which really means every single model, like Gwen has its own architecture on there. Llama has its own architecture on there. BERT has its own architecture, and so on and so forth. There is no standard architecture on there. That's also another reason of why you see Hugging Face Transformers being ahead of the curve is day one they can just use a model where Llama will need to go patch this. And really the disconnect we've seen there is you need to rewrite some chunks of Llama to just use Gwen 3 Next or use Gwen 3 VL because they have the vision model as part of the MOE layers now. That's something that Hugging Face just already does. Now finally, like I said, manual memory management, it does require some understanding, but the flip side is there's a lot of developer tooling there.
That's just a laser pointer.
That
doesn't change yours. That changes mine.
All right. Yeah, let me see, does this still
There you
work?
go.
Yeah, okay. Now, the other one I'm going to cover is VLLM. This is a very popular one for inference. Now, it is optimized for high throughput, and they have this concept called paged attention. All that means is, so typically right now, if you're going to run an attention mechanism, you know, the attention is just going to put everything onto one device, which means if your device gets overloaded, you're just going to crash in memory. Now, flash attention is trying to just control how the matrix of the attention model is being constructed. It does some smart things. But fundamentally what they now do is they can page the attention like memory, so you're not going to blow up. VLM is fully production ready out the box, which actually takes us some of the drawbacks. It's really heavy to set this up, and you do need a bigger GPU to really make VLLM worth your while. Like if you have a smaller GPU, I would say under 12 gigs, I really don't think you're going to get much value out of VLLM. Like just the fact that like you're going to be stuck in the paging of your attention. That's not great. Where if you have, for example, like a 3090 or a 4090, or if you're going to get a 5090 in this day and age, those models can't. Those GPUs can actually take off the taps of VLLM at home. So if you do have a lot of processes where you're constantly running, you know, tons of inference to LLMs, it is actually worth checking out VLLM. Especially, for example, if you're saying, you know, I got to process PDFs, I want to do a bunch of RAG, and I want to go use Open Web UI while I'm doing this. And that's the thing that gets most people is you're like, hey, I'm going to go to Open Web UI, and I'm going to go do Ollama stuff. Well, you're talking the same Ollama, and either one of the processes is waiting, or you're seeing a lot of processes are created, there's a lot of memory use. And in fact, the problem is that your hardware can start throttling what you're doing, so all of a sudden you're thinking, oh, I'm running all this stuff on GPU or on the M1 chip. You might see that the M1 chip just says, look, dude, I am so overheated right now, I'm just going to wait for the request. Now again, NVIDIA GPUs have heat sinks, that's not really the case there. But again, this is something VLLM is designed to actually overcome and be an inference platform. But like I said, it is not easy to use, and you're going to be paying for it. So let's look at an overall comparison. So now you can see ease of use. Essentially, Ollama is the easiest to use, where VLLM is really hard. But performance, I mean, Ollama is not actually great, does not support batching. But again, it just needs a CPU. They don't make any sort of assumption about your hardware. Now, this one, again, the Hugging Face one, not as easy to use. Very great performance. You can practically get fantastic performance out of this. It does have batching. You can control how much batching you give to the model. You can easily batch multiple requests all at once to that model, and it handles it under the hood with PyTorch. It is production ready. You can use Hugging Face transformers in production. I've certainly done that. And then again, I mean, the one GPU, you kind of need a GPU. You can, I want to say, use the Mac M1 chips and stuff like that, or whatever chip they're on now. You can definitely use them through Hugging Face. PyTorch is what it uses under the hood, but it can use other backends. Finally, VLLM is not easy to use whatsoever. In fact, I'll tell you, installing VLLM in and of itself is not easy. Just use the Docker if you want it easy to set up. And again, I mean, this could take hours to fiddle. You will get maximum performance out of VLLM. It has batching just out the box. And again, they really put batching as a first-class citizen. You walk through the documentary, the documentation they have, and they will try to talk you through how do you batch the requests, how many tokens do you want to allocate per request. They really make that very seamless to do, just out the box. But you kind of need a higher end GPU for that, and like I said, you're not going to get much gain if you have a tiny GPU, and VLLM does not work with the MacBook. It's not designed to. They're designed for GPU clusters. So with that, essentially some key takeaways. Ollama and Llama CP are easy for local development if you just want to get going. Hugging Face transformers, very flexible, very much on the cutting edge. Every model on Hugging Face that comes out, you can go use them. In fact, I'll tell you, when 3 was available, the architecture, couple days before the weights dropped. And that's something we see is that these frontier research labs do put out the architecture of the models on Hugging Face before the weights are even available, which means day one, the weights drop that hour, you can just go run the models. And you don't have to figure about, does the GGU good and all this other stuff. It just works out the box. If you have a production use case, like, you got to go inference on a bunch of GPUs, well, VLLM is really your only game in town. I know there's SG Lang. I've conveniently just decided to ignore it for this talk. That is viable. And again, I mean, VLM can use transformers under the hood as a backend. Not a bad option. But with that, I will open this up now to comments, questions, concerns, or anything else. Yeah.
Quick question. I know Llama uses Llama CPP, but Llama CPP also has a serving capability. Can you try that?
Also, repeat the question, please.
Yeah, so the question was that Llama CPP has serving capability. Have I tried that? I certainly have, and that's actually very true. I mean, Llama is essentially just a wrapper around Llama CPP. I certainly have, but I think at a fundamental level, I don't see how, a lot of the, for example, the tricks that VLLM has, or really the stuff that Hugging Face transformers and how low level you can work with that memory. I just don't think that their architecture and what they've optimized for allows you to just have that level of batching. Because if they actually had more dynamic batching, that would mean that that's more CPU activity. I think that there's just design choices they've made, and that was not their primary goal. Yeah.
From a software engineering perspective, so if you're going to put VLLM on one machine and put all the GPUs, that's not going to be very cost effective. Which one are the are more distributed friendly?
I would say VLLM is distribution friendly. You can distribute over all the GPUs you have. Hugging Face transformers can do the same. And if you actually look through their documentation, they do have a lot of documentation on how you can move the same model to multiple. But just remember, yeah, I would say VLLM is user-friendly if you can install it. The reason I say it's not easy to install is just because of... Oh, distributed-friendly? Yeah. Yeah, VLLM can be distributed-friendly if you want to distribute the same model and just have copies of it across. If you want to have one model that's sharded, you can do that with VLLM. As like I said, it does use transformers under the hood. Transformers will easily let you distribute a lot of those models. And they have documentation on how you can do that. Unfortunately, you do have to actually know something about the model, but because of the higher level interface transformers gives you, you can actually introspect the models themselves. They have this layer object that you can just check the layers. It's very doable. So while you do need to know something about the model, you don't need to know everything about that model. Yeah.
So a lot of the new, I guess, best frontier models are mixture expert models.
Mm-hmm.
And so I'd like to know if you looked at how each of these handle that, because for me, I've got a 4090 gig. It's been great for those small models like 2232B, but then now suddenly they come up with these great mixture expert models that use a lot more, tokens, but the aggregate tokens are smaller, yet it doesn't fit on the GPU. So, yeah, I'm kind of curious how people gotten that to work on things like local GPUs and which one of these systems, if any, works for that.
Yeah, so I think the question essentially is, let me make sure I understand it. So what you're saying is that, well, most of these mixture of experts models, they really have a much fewer activated parameters. So can they move some of that off and put those on? There have been some efforts to do that. I think the biggest challenge, though, is the fact that, if you are to look at which experts do you want to put on, you have a lot of activity at the CUDA layer, which means you're having to move data between CPU and GPU. So in theory, Llama CPP could do it more efficiently, but then again, there's the whole problem then of, how are you going to move those layers? And if you don't know that much about the model, and that's the problem with the GGF format, they don't want to know about what hardware you're running. But the problem is that if you know that it's on CUDA, you can make so many optimizations for that. I would say that that's probably an area that NVIDIA is most active in, is trying to figure out, how can they do it at the driver level and make it just map memories that are easy to swap. AMD has done a lot of work on that because they have the CPU and the GPU, and they're trying to have this hybrid architecture that they're there for. Unfortunately, MOEs are just way too new. I mean, they've really been only out for a couple of months, versus dense models have been there for years on end, which is kind of why you've seen that the quantization behind GGUF has gotten better and better now at this point, because, I mean, it is effectively almost a 2-year-old format now at this point. I mean, I know stuff is brand new. It is 2 years old now, where a mixture of experts have really only just come about. So that's kind of what you're seeing there. There's not a whole lot of mature support.
Unified memory, you have a better answer for it, but I'm asking for the answer for the...
Yeah, I mean, in theory they do because of that. In reality, memory management and all that stuff, that's where it's going to come in at the developer level. Yeah. How much VRAM? It really depends on the LLM. Do you have any in mind? Uh-huh. Mm-hmm. Yeah, so I think with those two, you could probably just run a 70 billion. You just distribute that across the two. You might be able to get away with running the biggest Gwen 3 MOE at 225 billion parameters. You're probably going to need quantization, though. Again, those are all doable. So you could definitely run with any of these frameworks on them. Again, I don't really know how well does Llama or Llama CPP distribute across multiple machines. That's really where VLLM and Hugging Face really let you just take care of that in ways that that are just designed for you to just saying, I want to put these layers here, I want to put those layers over there.
Awesome. Well, thank you so much.